We usually imagine the first galaxies as unfinished things, dim beginnings, loose accumulations of gas and young stars, still trying to become recognizable. But when James Webb began looking deep enough and clearly enough, some of those early galaxies did not arrive as vague rehearsals for the real universe. They arrived already concentrated, already intense, already gathered tightly enough to feel slightly wrong. And that small feeling of wrongness matters, because once you follow it carefully, it changes what the early universe was allowed to be. If you enjoy slow, deep journeys like this, you can stay with me through the whole thing. There is a strange comfort in letting the evidence lead. Now, let's begin with something familiar. Think of the difference between an old city and a new suburb. An old city tends to keep its life packed inward. Streets are tighter. Buildings rise closer together. Energy is concentrated. A suburb spreads. The same number of people can occupy a much wider area, with more room between everything. Most of us carry a version of that intuition into space without realizing it. We assume the early universe should have looked like the loose version, more empty, more provisional, more spread out. It sounds natural. Early should mean simple. That is the instinct Webb has been quietly disturbing. Some of the galaxies it sees from the first few 100 million years after the Big Bang appear strikingly compact. Not just distant, not just faint. Compact in the sense that much of their visible light is crowded into a very small physical region. In a few cases, what the telescope is resolving looks less like a sprawling future galaxy in its infancy, and more like a bright, compressed core doing an astonishing amount of work in a very small space. That distinction is easy to miss because distance can make everything look small. A plane high overhead and a coin held at arm's length can seem comparable in size. So the first thing to understand is that astronomers are not simply staring at remote smudges and declaring them tiny because they are hard to see. They are measuring how light is distributed, how concentrated it is, how much of it falls within a certain radius, how that profile changes with wavelength, and whether the object stays structurally tight even after better imaging and better modelling. This is cautious work, and even with that caution, the pattern has become hard to ignore. Some very early galaxies look crowded. That single word, crowded, gets us closer than some of the more technical language, because what Webb is revealing is not merely a geometrical curiosity, it is a physical condition. Matter was collapsing into dense regions, gas was flowing in, stars were forming in environments that may have been much more compressed than the broad, calmer galaxies we know nearby. The early universe was younger, yes, but it was also denser overall. Space had expanded less. The background conditions were different. The gravitational landscape was more pressurized, and when you begin there, the compactness stops feeling like a random oddity and starts feeling like a clue to speed. That's really the deeper shock hidden inside these images. A compact galaxy in the early universe is not just small, it may be telling us that structure assembled fast, that gas reached high densities quickly, that stars ignited in bursts, and that some galaxies began organizing themselves with a pace that does not match the softer picture many people still carry in their heads. We hear only 400 million years after the Big Bang, and imagine an almost empty rehearsal stage. But 400 million years is not nothing. It is enough time for entire mountain ranges to rise and erode on Earth, enough time for evolution to perform dramatic experiments, enough time for a system under strong pressure to become something much more elaborate than intuition expects. And pressure is exactly the point. If you compress the same ingredients into a smaller chamber, reactions change. A fire behaves differently in a tight furnace than in open air. Traffic behaves differently when lanes narrow toward a crowded center. Human beings behave differently when too much activity is forced into too little room. The early universe was not a peaceful blank slowly decorating itself. In many regions, it was more like a set of converging flows feeding dense pockets of growth. Dark matter pulled, gas followed. Cooling allowed matter to sink farther inward. Star formation turned on. Radiation and stellar winds pushed back. New stars enriched their surroundings. In some systems, all of this seems to have unfolded with startling efficiency. Which is why compact does not mean unimportant. In some cases, it may mean the opposite. A galaxy can be physically tight and still be bright, chemically active, and substantial for its age. That is one of the corrections Webb keeps forcing on us. We tend to equate size with significance, because in daily life, large things dominate our field of view, but in astronomy, a small region can hide extraordinary intensity. A compact early galaxy may be pouring out ultraviolet light from a concentrated star-forming zone. It may contain a rapidly growing stellar population. It may already show signs that multiple generations of stars have lived and died there, leaving heavier elements behind far sooner than a simple, gentle picture would suggest. You can feel the intuition break when that lands, because the phrase young galaxy starts to become misleading. Not false, just misleading. Young in age does not always mean simple in structure. Young does not mean diffuse. Young does not mean inactive. Some of these systems seem to have lived hard very early, and that creates one of the most interesting emotional reversals in the entire story. When we look far enough back, we're not only looking into childhood. In places, we may be looking into compressed lives. Galaxies that built quickly, blazed brightly, and in some cases may even have started changing phase before the universe was 1 billion years old. But before we go that far, we need to stay with the observation itself, because this is where the strangeness becomes tangible. Imagine expecting the outline of a village on a dark plain, and instead finding a lit downtown core, not a whole metropolis, not yet, but a density of light that makes you rethink the timetable. That is closer to the feeling. Webb is not finding identical objects everywhere. The early universe was diverse. Some galaxies are faint, some are irregular, some are clearly in the middle of assembly. The surprise comes from a striking subset that look unusually concentrated, unusually luminous, or unexpectedly developed in their internal structure. And once you notice that subset, a second question immediately appears. Are these galaxies truly compact in their underlying structure, or are we being shown the brightest parts first? Because light can mislead, a stage can look tiny if only one spotlight is on. A city seen from a distance can seem to consist only of its illuminated center. In the same way, a galaxy's most active star-forming regions can dominate the image, making the visible profile look tighter than the full distribution of matter really is. This is why astronomers have to be careful. Different wavelengths reveal different layers. Dust can hide some stars and emphasize others. Emission lines can brighten specific regions. Resolution matters, lensing matters, interpretation matters. Still, even after those cautions, the unease remains. Because in some of these galaxies, the concentration is not just a trick of poor vision, it survives scrutiny well enough to force a larger question. If early galaxies were really this structurally tight, then what else was happening inside them? How intense did star formation become in those cramped volumes? How quickly did they enrich themselves? And how soon did the universe begin producing systems that were not merely forming, but already changing shape, building cores, and rushing toward the next phase of their existence? That is where the story deepens, because once a galaxy appears compact, you are no longer just talking about size, you're talking about conditions, and conditions, in the early universe, may have been far more severe than the word early ever prepared us for. Those conditions are easier to grasp if we stop thinking of galaxies as finished objects and start thinking of them as environments. A galaxy is not just a shape in the dark. It is a place where gravity is trying to gather, gas is trying to cool, stars are being born, stars are dying, radiation is pushing back, and every one of those processes changes the ones around it. In the nearby universe, we often see the long result of that struggle: broad disks, extended halos. Systems that have had billions of years to stir themselves, merge, settle, and spread their light over enormous distances. Webb is staring into a much earlier stage, where the same processes may be happening under tighter constraints. That is why compactness has so much force. It implies crowded interactions. A useful way to feel it is to imagine not the total population of a city, but its population density. Two cities can contain similar numbers of people, and yet feel completely different if one is spread over hundreds of square miles, and the other is compressed into a small island of towers, traffic, heat, and noise. The early galaxies Webb is catching are often more like the island city. Their light is not leisurely distributed, it is piled inward. And when a lot of gas, radiation, and gravitational energy are forced into a smaller physical region, the pace of events can change. This is where the story stops being mainly visual and becomes physical. Many of these early galaxies are not only compact in appearance, They're also bright in ways that suggest intense star formation. Their spectra often show strong emission lines, which is a more technical way of saying that the gas inside and around them is being excited very effectively. Young, hot stars are flooding their surroundings with energetic light. At the same time, the signatures astronomers read from that light imply that some of these systems were forming stars rapidly and, in some cases, enriching themselves with heavier elements faster than older expectations allowed. That last point matters more than it first appears to. At the beginning, the universe was mostly hydrogen and helium, the heavier elements that make rocky planets, blood, dust, mountains, electronics, and bones had to be manufactured inside stars and then expelled back into space through stellar winds and explosions. So when Webb looks at very distant galaxies and sees evidence that some of them are already chemically active and not completely pristine, it means at least some stellar generations have already come and gone. Time has already been spent. Work has already been done. The darkness has already been altered. And if all of that happened in a compact volume, then the image becomes even stranger. You're no longer looking at a loose beginning. You're looking at a compressed workshop. A workshop under pressure? There is an old habit in popular descriptions of the cosmos to make the early universe feel delicate. Everything starts as a glow. Then gentle structures emerge. Then complexity arrives much later. There is truth in that broad arc, but it can soften the reality too much. Because the first billion years were not merely a soft dawn. In many regions they were crowded, unstable, and energetically expensive. Gas did not drift forever before doing anything interesting. Gravity kept narrowing the options. Matter fell inward along filaments. Halos of dark matter provided scaffolding. Baryonic gas cooled and sank deeper. Once stars turned on, they transformed the local environment almost immediately. You can think of it as a room changing its own weather. A dense pocket of star formation does not quietly sit there. Hot young stars emit powerful radiation. Stellar winds carve into nearby gas. Supernovae inject energy, turbulence, and newly forged elements. Some of that violence can trigger more collapse elsewhere. Some of it can suppress it. The environment becomes self-modifying, and in a compact galaxy, those effects do not travel through huge empty distances before meeting something important. They happen close. Feedback becomes intimate. That intimacy may be part of why compact galaxies are so revealing. They show what happens when the universe does not have much room for hesitation. Of course, caution belongs here. Astronomers are not simply measuring an entire galaxy with a cosmic ruler and announcing final truth. Often what is being quoted is a half-light radius, the distance within which half the observed light is contained. That is a valuable measurement, but it does not mean we have captured every faint outer component. A galaxy can be more extended than its brightest visible core suggests. Dust can hide parts of it. Certain wavelengths may emphasize the most active regions. A concentrated ultraviolet image may trace where stars are forming most intensely, not necessarily the full spread of older stars. So compactness is not a naive statement. It is an observational result that has to be interpreted with care. But careful does not mean weak. Even once all of those complications are admitted, the emerging picture is still striking. Some early galaxies really do seem to have extremely small effective sizes. Some show dense cores, some appear to combine high brightness with tight structure in ways that suggest efficient assembly. And what makes the picture more compelling is that this is not resting on one sensational object. It is becoming a pattern across growing samples. Patterns change the emotional texture of a discovery. A single bizarre galaxy can always be filed away as an exception, a fluke, a temporary phase, or a measurement artifact waiting to be corrected. A repeated tendency is harder to dismiss. When a telescope begins revealing not just one improbable city of light, but many compact districts in the early dark, our internal model has to adapt. The question is no longer, did we find one weird thing? It becomes, what kind of universe produces this often enough for it to be part of the background story? That is when the pace of cosmic history itself starts to feel different. Because compactness is really a time story wearing a size disguise. A galaxy that has already concentrated substantial light, formed many stars, and begun shaping its own internal conditions only a few 100 million years after the Big Bang is telling us that assembly could be rapid, not universal, not uniform, but rapid in certain regions. Matter did not need to spend ages in a vague state before becoming structured. Under the right conditions, the universe could build quickly. You can feel how far that cuts against ordinary intuition by bringing it down to human scale. Imagine being told that a neighborhood is newly built, then arriving to find not scaffolding and open lots, but narrow streets, crowded apartments, glowing windows, repair shops, food smoke, traffic, and the first signs of wear. You would not say the place is old in an absolute sense. You would say it got busy fast. That is close to what Webb is showing us. Some early galaxies were not ancient. They were accelerated. And acceleration leaves marks. One of those marks is burstiness. Instead of forming stars at a slow, even rate, many high redshift galaxies appear to go through intense episodes. They light up. They consume gas quickly. Their energetic output rises sharply. Then feedback may alter the environment, reducing the pace or shifting where new stars can form. This bursty behavior matters because it means a galaxy's appearance at one moment may capture it in a brief but dramatic phase. If you look during the outpouring, the whole system can seem more extreme than its long-term average. That possibility is important because it gives us one partial explanation for why some early galaxies look so startling. We might be catching them at their loudest moment, but that is only a partial explanation. Because even a brief outburst has to happen somewhere. The gas still has to be there. The stars still have to ignite. The structure still has to support the event. A starburst does not rescue us from the reality of compactness. It intensifies it. It says the compressed geometry was not passive. It was active enough to flare. And once you accept that, another question starts pressing in from the dark. If some of these galaxies could gather themselves this quickly, radiate this intensely, and chemically evolve this early, then how far did that rapid evolution go? Were we only seeing galaxies being born? Or were we already seeing some of them becoming something more organized than birth alone would predict? Because in a few Webb images, the answer begins to look less simple than anyone would have preferred. That complication enters the story the moment structure starts to appear inside the compactness. It would be one thing if all of these early galaxies looked like unresolved bursts, little knots of light with no internal suggestion of order. That would still be exciting, but it would keep the interpretation simple. They would be intense because they were young and chaotic. Yet some of the more careful Webb observations have suggested something harder to place so neatly. In at least a few early systems, astronomers have seen hints of differentiated structure, a compact central region, a surrounding star-forming component, perhaps a disk-like arrangement, perhaps clumps, perhaps an organization that already looks less like pure scatter and more like architecture. Architecture is the dangerous word here. Not because it is wrong, but because it pulls too much meaning too quickly if we are not disciplined. We should not imagine fully settled modern spiral galaxies hanging in the first few 100 million years as if cosmic time had simply skipped ahead. That is not what the evidence says. These are still young systems, often irregular, often actively forming stars, often messy in ways that nearby galaxies are not. But messy is no longer the whole story. Some of them appear to be messy in organized ways, and that is where the unease deepens. Because a compact galaxy with internal structure is not just a bright ember, it is a system already beginning to divide itself into roles. A center, a surrounding body, distinct zones of activity, maybe not in every case, maybe not permanently, maybe not as cleanly as our nearby examples, but enough to make the old intuition feel increasingly fragile. We expected infancy, and found signs of differentiation. We expected rough beginnings and found compressed systems already carrying hints of hierarchy. The universe had not merely started making galaxies. In some places, it had already begun making varieties of galaxy behavior. The language astronomers use for this is measured, and it has to be. The images are difficult, the interpretations careful, the sample still growing, but emotionally, the shift is sharp. The farther back Webb looks, the less the early universe resembles a blank developmental stage waiting patiently to become interesting. It already contains local histories, already contains consequences, already contains places where enough has happened for one part of a galaxy to differ meaningfully from another. You can picture it in a bodily way. A wound does not simply close. The body begins organizing a response. Tissue thickens in one place. Inflammation rises in another. Blood flow changes. repair begins, sometimes overreacts, sometimes leaves scars. A living system under pressure differentiates. Early galaxies seem to have been doing something like that at cosmic scale. Under the pressure of gravity, gas inflow, radiation, and feedback, they were not staying uniform for long. That makes compactness feel more consequential. A compact system is easier to imagine as a single event. A compact system with structure becomes harder to dismiss as a temporary glare. It begins to look like a place with an internal past. And that is where chemistry comes back in. Because morphology alone can still leave room for illusion. A bright clump can imitate a core. A favourable viewing angle can distort our sense of shape. But when structural hints arrive alongside signs of strong star formation and non-primitive chemical conditions, the picture thickens. The galaxy is not simply arranged. It has been processing matter. It has been making stars, recycling material, altering its own composition. The inner life of the system is becoming visible through its light. This is one reason early Webb findings felt so disorienting to astronomers without necessarily feeling impossible to them. The broad framework of cosmic evolution was not overturned. Gravity still gathers matter. Dark matter still provides scaffolding. Galaxies still grow by accretion and merger. But the timetable inside that framework began to feel less relaxed. The first galaxies were not violating the basic script. They were performing parts of it faster, or more efficiently, or under conditions that made familiar timelines feel overly comfortable. Speed again! It keeps returning because size, brightness, chemistry, and structure all keep translating into a question of pace. How quickly can gas fall inward? How quickly can stars ignite? How quickly can those stars enrich the surrounding medium? How quickly can concentrated star formation build a central density? How quickly can feedback begin reshaping the environment it emerged from? This is why the title promise keeps expanding. Strangely compact does not remain a statement about spatial extent. It becomes a way of saying that the early universe may have been running certain local processes at a startling tempo. Still, there is another possibility that must be faced, because it is one of the cleanest ways nature can fool us. What if some of the compact galaxies are not single, self-contained systems at all? What if they are crowded scenes? What if what first looked like one astonishingly bright and concentrated object turns out, under better imaging or spectroscopy, to be multiple galaxies in the act of approaching, interacting, or overlapping along our line of sight? That matters because merging galaxies can create enhanced brightness, irregular shapes, and tightly clustered light. A merged or merging system can look more mature, more massive, or more extreme than any one of its components would alone. And this is not hypothetical in the empty sense. Webb has already shown that at least some early anomalies become less shocking when higher quality data resolve companions, or reveal that what seemed singular was actually multiple. The telescope is not just exposing distant galaxies, it is exposing crowded neighborhoods. In some cases, that helps. One fuzzy headlight becomes several vehicles converging in the dark. A supposedly impossible early giant turns into a set of smaller galaxies caught mid-assembly. The pressure on theory eases a little. But only a little, because once again, the explanation does not erase the environment that made it possible. If the early universe was producing dense, merger-rich regions where multiple galaxies could crowd together and interact this quickly, that is not a collapse of the mystery, it is a refinement of it. We still end up with rapid assembly, fast local growth, and a universe capable of creating complex scenes early. A merger can lower the tension on one measurement while increasing the vividness of the underlying reality. There is something almost human about that. We search for the interpretation that makes the surprise smaller, then discover that the corrected version is still extraordinary, only in a more grounded way. The galaxy is not a lone, impossible monster. It is part of a crowded and evolving district, better, more believable. Also, in some ways, more intense. And mergers themselves can contribute to compactness in meaningful ways. When galaxies interact, gas can be funneled inward, central star formation can rise, structures can be disturbed and compressed, bright clumps can ignite. What looks like a compact core may in some cases be the luminous consequence of an encounter. The early universe, already denser and more active, may have offered many opportunities for this. Not endless collisions everywhere, but enough interactions to make crowded assembly part of the story. So now the picture has become more textured than the initial shock suggested. Compact early galaxies may be compact for more than one reason. Some may truly be intrinsically concentrated systems. Some may be observed during bursty episodes that make their central regions dominate the light. Some may be products of mergers or interactions. Some may combine all of those factors at once. This is not an annoyance. It is the real shape of frontier science. A single dramatic sentence dissolves into a more complex reality, and the more complex reality turns out to be even more revealing. Because every version still says the same uncomfortable thing. The early universe was not waiting around. Matter was gathering, concentrating, colliding, igniting, enriching, and reorganizing itself in ways that can no longer be described as merely tentative. The question is no longer whether the first few 100 million years contained structure. They plainly did. The question is how far that structure had already gone by the time its light began the journey toward us. And that question becomes even harder to ignore when some of the galaxies Webb sees do not merely look concentrated or active. They look as if they may already have begun passing through phases we once imagined belonged to a much later cosmic age. That possibility sounds almost unfair at first. We spend so much time adjusting to the idea that very early galaxies could already be bright and dense that it feels excessive to ask for more. But the evidence has been nudging in exactly that direction. Some early systems do not just appear to be assembling quickly. They show hints that parts of their rapid growth may already have run into limits. In other words, the story may not be only about ignition, it may also be, in a few cases, about exhaustion. To feel why that is so startling, it helps to remember what quenching means in the life of a galaxy. A star-forming galaxy is actively turning cold gas into new stars. A quenched galaxy, or a galaxy entering a quenched phase, has slowed that process dramatically. It is not dead in the human sense, but it has lost some of the vigorous fuel-burning behavior that defines a youthful, active system. In the nearby universe, and even in much of the earlier universe already studied before Webb, quenching is something we often associate with galaxies that have had time to grow, consume, disrupt, or expel their gas over long stretches of cosmic history. Now imagine seeing a hint of that only a few 100 million years after everything began. It is like arriving in a newly built neighborhood and finding not just construction and traffic, but the first closed storefronts, the first signs of strain, the first evidence that some blocks have already lived hard enough to change character. Not old in any absolute sense, just fast enough to have already passed through one major phase and begun another. That is the emotional force of these early compact galaxies when they are paired with evidence of reduced star formation or post-starburst conditions. The universe was young, but some of its galaxies may already have been aging in compressed time. Compressed time is the deeper reality beneath this whole subject. We tend to treat time as a uniform substance. 100 million years is 100 million years. That is true mathematically. But it is not always true experientially inside physical systems. Under different conditions, the same amount of time can contain very different histories. A century in a quiet rural town and a century in a capital city under war, industry, migration, and political upheaval do not feel like the same quantity of lived change. The early universe may have been like that. Not all places equally active, not all systems equally rushed, but certain galaxies seem to have passed through extraordinary amounts of internal change in what, from our late perspective, still feels like almost no time at all. This is where compactness becomes emotionally larger than size. A compact galaxy can concentrate not only matter, but biography. A system that forms stars intensely in a small region, enriches itself quickly, and then begins to suppress or alter its own star formation, has effectively packed multiple chapters into a short span. Youth, exertion, feedback, maybe partial shutdown. The first time you really let that possibility settle in, the phrase cosmic dawn changes flavor. Dawn suggests freshness, dew, soft arrival. But some of these galaxies seem to have experienced something closer to a hard morning shift in a cramped industrial district. Lights on early, engines already hot, fuel burning fast, the first signs of wear arriving before noon. Again, caution matters. A recently quenched or mini-quenched galaxy in the very early universe is not a blank check for dramatic conclusions. It may not stay quiet forever, it may reignite. The observational signatures have to be interpreted carefully. Dust can complicate the picture. Bursty histories can mimic other states. We are still dealing with frontier data, growing samples, and models being actively tested against new observations. But the point is not that astronomers have declared the case closed. The point is that this possibility now exists in serious discussion at all. And once it exists, the whole scene shifts. Because a compact early galaxy is no longer just evidence that stars can form in a small region. It becomes evidence that local cycles of growth and change may have been much more accelerated than a generic mental image of the young universe ever allowed. Suddenly, the early cosmos begins to feel less like a simple beginning and more like a compressed era with its own fast internal seasons. There is something humbling about how alien that is to human intuition. We are creatures of rooms, roads, weather, and faces. Our instincts were built to judge size across a valley, not across billions of light years. They were built to estimate age from wrinkles, rust, and seasons, not from spectra and redshift. So when we hear that a galaxy existed 600 or 700 million years after the Big Bang, many of us imagine it as a child because the universe itself was young. But the universe does not care about that metaphor. It cares about local conditions, density, inflow, cooling, gravity, turbulence, feedback. A physically young era can still produce systems with unexpectedly advanced internal histories. And that realization leads to a deeper correction. The opposite of old is not always simple. That line is worth staying with, because it reaches beyond astronomy. We carry it everywhere. We assume the early phase of anything must be rough, slow, and undeveloped. But intense systems can organize very quickly when pressure is high enough. They can also overspend quickly. That is why compact early galaxies feel so alive as a subject. They are not just remote data points. They are reality pushing back against the comforting rhythm we wanted to impose on it. By this point, though, another question begins to rise naturally. If some of the early systems are compact because they are genuinely concentrated, and some because we are seeing bright central starbursts, and some because interactions or mergers help pile light inward, and some perhaps because they are already entering a changed phase after an early growth spurt, then how common is all of this? Are we building a cosmic mood from a handful of spectacular cases? Or is Webb showing us something broader about the statistical shape of early galaxy evolution? That matters because individual objects can be intoxicating. A single galaxy with an astonishing profile is easy to remember. It becomes an icon. But icons are dangerous if they stand in for the whole sky. Science becomes more powerful when the headline object is folded back into a population. Webb is now doing that. Larger surveys are providing wider context. Instead of asking only whether one early galaxy looks strangely tight, astronomers can begin asking how galaxy size changes with time across samples, how compactness relates to stellar mass, how brightness and morphology correlate, and how often these concentrated systems appear in different cosmic neighborhoods. The broad answer so far is not that every early galaxy was compressed beyond recognition. Diversity remains real. The young universe held faint systems, irregular systems, dusty systems, interacting systems, likely extended systems, and objects that resist clean categorization entirely. But compactness has not vanished as the samples grow. It keeps returning as a meaningful part of the picture. Not universal, not isolated, but persistent enough to influence how we talk about the first billion years. That persistence has a quiet authority to it. It means we are moving past the emotional phase of surprise and entering the more demanding phase of revision. The story now has to be rebuilt with this feature inside it. And the rebuilt story is richer. Instead of a uniformly primitive universe slowly producing recognizable galaxies, we have a more uneven landscape. Some regions seem to build quickly. Some systems may gather matter with unusual efficiency. Some compact objects may be the illuminated cause of larger structures we only partly see. Some may be caught in brief, brilliant episodes. Some may be interacting. Some may already be feeling the consequences of their own early intensity. This is messier than the old popular image, but it is also more real. What emerges is not a broken cosmos. It is a cosmos with stronger local contrast than we expected. That is important, because there is a cheap version of this story that tries to turn every Webb surprise into a total overthrow of modern cosmology. It is tempting. It flatters the appetite for crisis. It makes the telescope seem more dramatic than reality needs it to be. But the stronger truth is quieter and, in the long run, more interesting. Webb has not made the universe less intelligible. It has made it less simplified. It is sharpening questions about efficiency, feedback, dust, assembly, timing, and observational bias. It is forcing models to grow more precise. It is not telling us that the Big Bang never happened. It is telling us that the first chapters after it may have been denser, faster, and more structurally inventive than our softened imagination had prepared us to see. And that brings us back to those compact early galaxies with new weight. They are not merely surprising images. They are arguments from light, arguments that some parts of the early universe got busy very fast, arguments that intensity does not wait politely for maturity, arguments that the distant past was already beginning to sort itself into centers, outskirts, bursts, collisions, and maybe even silences. Once that is in view, the next thing we have to confront is not just how those galaxies looked, but what the surrounding universe had to be like to make such concentrated lives possible at all. To answer that, we have to widen the frame without losing the intimacy of the image. A compact galaxy is a local event, but it only makes sense inside a larger cosmic environment. No city rises from nothing. There are supply lines, geography, pressure, incentives, constraints. The same is true here. If the first few 100 million years produced galaxies with such concentrated light and such rapid internal change, then the surrounding universe must have been delivering material, structure, and timing in ways that encouraged compression. This is where dark matter quietly returns to the center of the story. We cannot see dark matter directly, but galaxies form inside its gravitational scaffolding. Long before stars were shining in large numbers, dark matter had already begun clumping into halos, drawing ordinary matter toward regions where gravity was stronger than average. Gas fell into those potential wells. It heated, cooled, settled, and under the right conditions condensed further. Without that hidden architecture, there are no galaxies. And in the early universe, the architecture was forming under denser overall conditions than the ones we live inside now. The scaffolding was younger, yes, but the stage was tighter. Matter had less expanded space in which to disperse. That does not mean everything happened instantly. It means the starting pressure was different. A useful way to feel it is to stop imagining cosmic history as a slow-motion unfurling and instead imagine a landscape after heavy rain, where every dip in the ground quickly gathers water. The dips are not the same size. Some remain shallow puddles, some become streams, some feed larger basins. In the early universe, dark matter halos were the dips, and gas was the water responding to gravity. The details were vastly more complex than a rain-soaked field, but the intuition helps. Once the conditions favored collapse, material did not simply hover in indecision, it moved towards structure. And when it moved, it did not move in isolation. The universe on large scales has a web-like structure, with filaments of matter threading between denser knots. Galaxies are not sprinkled randomly like salt. They emerge within this larger architecture. Gas can flow along those filaments into halos, feeding growth. In some regions, that means a compact early galaxy may have been living at the end of a supply route, receiving fresh material in a way that allowed rapid star formation to continue longer than a closed system could sustain. So when we see an early object that seems almost too active, one of the questions is not only what it is doing internally, but what kind of cosmic neighborhood is sustaining it. This matters because compactness can be mistaken for isolation in the imagination. A tightly concentrated object feels self-contained, but the opposite may be true. A compact galaxy can be the bright, compressed outcome of a much larger network of inflow, environment, and interaction. The visible core may be only the point where wider cosmic traffic is crashing into itself most efficiently. That is one reason the early universe may have been able to build so quickly in certain places. Not because everything everywhere was instantly mature, but because some nodes in the cosmic web became effective collection points. Gas arrived, gravity deepened, cooling allowed further collapse. Star formation became intense. Feedback modified the local conditions but did not necessarily shut them down immediately. The result could be a galaxy that looks astonishingly concentrated and yet is really the visible tip of a larger process. You can almost picture it as a harbour city at the mouth of several trade routes. The city itself is crowded, energetic, and bright at night. But its intensity does not come from nowhere. It comes from everything flowing into it. That broader view helps resolve one common emotional trap in this subject. People hear that galaxies were appearing compact and unexpectedly active early on, and they imagine astronomers looking at something impossible in an empty universe. But the universe was not empty. It was becoming structured. The cosmic web was already guiding matter. Halos were already growing. Some regions were already dense enough to feed rapid assembly. In that sense, the surprise is not that galaxies formed at all. The surprise is how efficiently some of them seem to have taken advantage of the conditions available. Efficiency is a more interesting word than impossibility. It lets us keep the wonder without falling into theatre. A compact early galaxy does not have to be magical to be startling. It only has to be a little too good at converting opportunity into structure, a little too good at gathering gas, a little too good at turning that gas into stars, a little too quick at creating the kind of concentrated brightness and internal differentiation that we once assumed needed much longer. Webb's results have kept sharpening that question. Not whether galaxy formation works, but how hard it can run when conditions are favourable. And once we ask that, another subtle shift happens. We begin to see nearby galaxies differently too. The Milky Way feels spacious to us because we live inside a late, extended system. Its disk is broad, its structure is distributed across enormous distances, its major star-forming regions occupy only parts of a much larger whole. Even when something dramatic happens in our galaxy, it unfolds inside a system that has had billions of years to accumulate layers, redistribute stars, and settle into an architecture we find familiar. That familiarity is dangerous. It makes us think this spaciousness is the natural shape of a galaxy. Webb is reminding us that it's also the result of age. Nearby galaxies are, in a sense, old neighbourhoods that had time to sprawl. The early compact galaxies are something else, more vertical, more compressed, more like districts built under urgency, where the centre carries a disproportionate amount of the light and the activity. They are not miniature versions of the modern universe waiting to scale up. They are products of a different era, with different pressures, and that means we should resist describing them only by what they lack compared with galaxies today. It may be better to describe them by what they reveal about their own time: high density, rapid inflow, bursty histories, energetic feedback, and in some cases a surprising ability to become internally complex before the universe was even 1 billion years old. There is a quiet dignity in letting them remain themselves instead of treating them only as early drafts of us. That sounds like a poetic point, but it is also a scientific one. One reason the compact galaxy story matters is that it helps break the habit of reading the early universe as merely incomplete. Incomplete relative to today, yes, but not empty of character, not empty of the local histories, not empty of hard-won structure. These galaxies were not just on their way somewhere. They were already living under real conditions that shaped them dramatically in the present tense of their own era. And because their present was so physically compressed, the consequences could arrive quickly. This is where feedback comes back into focus. Once stars form intensely in a compact region, their radiation and explosions can begin changing the fate of the surrounding gas almost immediately. In a larger, more diffuse system, those effects may take longer to reorganize the environment. In a compact one, the same energy can have outsized local consequences. Gas can be heated, pushed outward, fragmented, or rendered less available for further star formation. At the same time, inflows from the wider environment may continue feeding the system. So a compact early galaxy can become a tug-of-war between inward supply and outward disruption. That tension is one of the reasons these objects are so scientifically valuable. They are not calm. They are dynamic in a concentrated way. They allow astronomers to study what happens when assembly and self-interference occur in close quarters. You can feel how different that is from the old public image of the first galaxies as gentle, diffuse wisps in an otherwise patient cosmos. Webb is not showing us a tranquil nursery. In at least some places, it is showing us a crowded workshop where gravity and feedback were already arguing, and argument produces variety. Some galaxies may remain active, some may flicker through bursts, some may merge, some may lose gas and become temporarily quiet, some may hide behind dust, some may reveal only their brightest central regions while outer structures remain faint and difficult to see. The more we learn, the less likely it becomes that one clean sentence will ever summarize the first billion years. But that is not a weakness in the story. It is the payoff. Compactness was the doorway. Through it, we are arriving at a universe that is not simpler than expected, but more alive. By now, though, another problem has become impossible to ignore. If these compact galaxies are telling us about extreme local conditions, then how much of what we are seeing is truly their structure, and how much is a consequence of how light behaves on its way to us? Because before we can trust the emotional weight of these images completely, we have to pass through one more layer of humility, the difference between what a galaxy is and what its light lets us infer. That humility is not a side note, it is part of what makes the whole story credible. When Webb sees a galaxy from the first few 100 million years, it is not seeing the object the way you would see a building across a river. It is receiving ancient light that has been stretched by cosmic expansion, filtered through instrumentation, shaped by wavelength, and interpreted through models that translate brightness into structure. The images are real, the measurements are careful, but they are never the same thing as direct, everyday sight. And if we forget that, we start treating the telescope like a window when it's really something subtler, a translator. A good translator can reveal a world. It can also remind you that every revelation arrives through a medium. That matters especially with compact galaxies because so much depends on where the light is coming from. If most of the visible output is dominated by intensely star-forming clumps, then the galaxy can appear more concentrated than its full stellar body really is. If dust hides older or more extended components, then the visible profile can become misleadingly tight. If one wavelength emphasizes hot young stars while another is more sensitive to older populations, then different observations can tell different structural stories about the same object. Compactness, in other words, is not a cartoon fact. It is a measured property of a light distribution that must be read with care. And yet the care does not dissolve the signal. That is the important balance to hold. Scientific caution is not the same as scientific retreat. Astronomers worry about surface brightness limits because faint outer regions can slip below detectability. They worry about resolution because a source that looks singular may later split into components. They worry about lensing because gravity from intervening mass can magnify and distort distant objects. They worry about line emission because bright spectral features can alter inferred sizes and brightnesses. All of that is real. All of it matters. But after those worries are taken seriously, a significant number of early galaxies still appear remarkably compact. You could say the surprise has survived contact with skepticism. That is why it has remained such a productive topic. Not because the first dramatic reaction held untouched, but because it was refined and still stayed interesting. A weaker telescope can create mystery by leaving too much unresolved. A better telescope creates a deeper kind of mystery. It resolves enough to make the object more believable, but not enough to make it ordinary. Webb has done that repeatedly. It has not simply intensified the strangeness of the early universe. In many cases, it has made the strangeness more disciplined. Take mergers again. Before better data, a very bright early source might tempt people toward the most extreme interpretation, a single, implausibly massive galaxy appearing far too soon. Then improved observations separate that source into several interacting components. On the surface, that sounds like a reduction in drama. The impossible object becomes a crowded scene, but what replaces it is not dull. It is a knot of galaxies in rapid assembly, perhaps feeding one another's activity, perhaps compressing gas, perhaps making the local environment even more physically vivid than the original simplified headline suggested. The same pattern applies to size. A measured half-light radius does not tell you every secret of a galaxy. It tells you where half the observed light lives. That might be enough to reveal a truly concentrated system. It might also be a clue pointing toward a bright core embedded in something fainter and broader. Astronomers know this, which is why they compare data across filters, model light profiles, check for companions, estimate how much may be hiding under the noise floor, and revisit objects as better observations arrive. But here again, the mature version of the story remains powerful. Even when you allow for hidden outskirts or bright central bias, many early galaxies still look more crowded than the older public imagination of cosmic dawn had prepared us for. And that older imagination had one major weakness. It was shaped by distance without enough resolution. Before Webb, much of the early universe was seen in a more suggestive way than a revealing one. Hubble changed everything in profound ways, But Webb pushes farther in wavelength and depth and resolution for these remote epochs. It can turn what felt like a broad category into a textured population. That matters because the human mind is comfortable filling blurry regions with simplified narratives. If the first galaxies are mostly unresolved, we can project almost anything onto them. Innocence, vagueness, smooth growth, a kind of cosmic childhood. Webb interrupts that projection. It gives the distant past edges. Edges change emotion. A blur lets you keep your myth. A resolved structure begins asking something of you. It asks you to admit that the early universe had neighborhoods, gradients, concentrations, and probably local dramas already underway. It asks you to stop using young as a synonym for featureless. It asks you to accept that the first chapters of cosmic history may have contained more internal contrast than our metaphors were built to handle. There is another reason this observational humility matters. It keeps us from turning compactness into a single moral lesson. The universe is rarely that cooperative. Some compact galaxies will turn out to be less extreme than first reported. Some will prove to be multiple systems. Some will show hidden outer components. Some will be bright because we caught them during a brief outburst. That is not failure. That is how a living scientific picture becomes trustworthy. You do not want a frontier field in which every first impression survives untouched. You want one in which the picture sharpens, sheds excess certainty, and still leaves you with a stronger pattern than you had before. That is exactly what seems to be happening here. The pattern that remains is this. In the first billion years, and especially in the earliest observed slice of that era, a notable fraction of galaxies appear structurally tight, highly active, and more internally consequential than many people expected, even after accounting for measurement challenges. They continue to suggest that at least some regions of the young universe assembled stars and concentrated light with remarkable efficiency. The details are being refined. The broad revelation is holding. And when a revelation holds through refinement, it starts changing not just the data, but the imagination around the data. This is a good moment to notice how unusual that is. Most of human history passed beneath a night sky that looked calm and fixed. Even after astronomy taught us that stars are suns and galaxies are island universes, the deep past still remained psychologically abstract. We could know it was there without feeling its texture. Webb is altering that relationship. It is letting us feel the first few 100 million years not as a blank category, but as a place with densities, bottlenecks, bright cores, collisions, and maybe even the first exhausted systems already emerging from their own early excess. In a strange way, the telescope is making time more physical. Instead of thinking only in years, we can think in conditions. A galaxy only a few 100 million years after the Big Bang is not merely earlier on a line. It exists in a different pressure regime, a different density regime, a different observational regime too, where much of what we see is mediated through the brightest available light. So our task is double. We have to let the image disturb us, and we have to let the measurement discipline the disturbance. When both happen together, the result is stronger than either simplicity or hype. And it brings us to a harder question than the original one. Not just why some galaxies appear strangely compact, but what that compactness is doing to the fate of those galaxies themselves. Because once matter, gas, radiation, and feedback are forced into close quarters, structure does not merely become visible, it begins to reshape its own future. Some of these early systems may have been compact not only in how they looked, but in how quickly consequences arrived. That is where the story begins to tilt from appearance into destiny. Destiny, in a galaxy, is mostly a question of fuel and force. If enough cold gas keeps arriving, stars can continue to form. If that gas is heated, scattered, consumed, or blown out faster than it is replaced, the galaxy changes character. In a very extended system, these contests can play out over long distances and over long intervals. In a compact one, the same contest can become intimate. Radiation does not have far to travel before it reaches more gas. Shockwaves do not cross empty outskirts for ages before meeting something important. The stars that are born into a dense environment begin influencing neighbouring material almost at once. The galaxy becomes a place where cause and consequence are packed close together. That closeness may be one of the hidden meanings of Webb's compact galaxies. They are not only revealing how quickly the universe could build, they're also revealing how quickly the products of that building could begin interfering with the next round of growth, There is a useful human-scale analogy here, and it has nothing to do with drama. Imagine a body under sudden, intense strain. Energy use rises, heat rises, hormones shift, repair mechanisms activate even while exertion is still happening. The system is not waiting for the effort to end before it begins reacting to the effort. It is adjusting in real time. A compact star-forming galaxy may behave in a roughly similar way at cosmic scale. While gas is still pouring inward and stars are still forming, feedback is already modifying the environment, changing how the next stars will or will not emerge. That can produce a strange compression of history. A galaxy can be gathering itself, brightening, enriching its gas, and partially suppressing its own future growth, all in the same general era. This is one reason the earliest compact systems feel so conceptually rich. They are not snapshots of one simple phase. They may be snapshots taken while several phases overlap. Assembly, turbulence, concentration, disruption, birth and self-resistance at once. And the smaller the active region, the harder that overlap can bite. If you squeeze a lot of star formation into a region only a few hundred parsecs across, the energy density changes. Supernova explosions do not feel abstract there. Radiation fields do not remain politely local. Stellar winds do not vanish into spacious anonymity. They matter to nearby gas because nearly everything is nearby gas. This does not guarantee quenching. It does not mean every compact galaxy burns itself out. But it does mean that the consequences of activity may arrive faster than they would in a looser, more extended system. That is part of why compactness keeps pointing beyond itself. It is a structural clue that opens into a dynamical one. What did these galaxies do after the light we now see left them? Some likely kept growing. Some merged into larger descendants. Some may have puffed outward as stars accumulated and interactions redistributed matter. Some may have gone through repeated bursts, fading and reigniting as new gas arrived. Some may have become the dense central cores of later, larger galaxies, their early compactness preserved as a kind of fossil inside a more sprawling future system. That possibility has enormous weight, because it suggests the first compressed structures may not only be curiosities of cosmic dawn, they may be ancestors still hiding inside the galaxies of later ages. In that sense, a compact early galaxy could be a seed and a scar at the same time. A seed because it is the concentrated beginning of a larger structure to come. A scar because it records how hard and how fast the early universe forced matter to organize. We tend to think of growth as expansion, and often it is. But some growth begins with concentration. A dense core forms first, then later history layers itself around it. That is familiar in human construction too. Old city centers often stay denser than the suburbs that grow around them later. The crowded original district remains legible beneath centuries of outward spread. Webb may be catching something analogous in the universe, early dense centers that later cosmic history will build upon, obscure, distort, or preserve. That possibility turns compactness into memory. The shape of a galaxy can remember the conditions under which it formed, not perfectly, not forever, but enough. A dense central region can carry forward the imprint of an earlier pressure regime. This is one reason astronomers care so much about how galaxy size evolves with time. It is not just a cataloguing exercise, it is a way of asking whether the structures we see nearby contain a fossil record of harsher beginnings. When Webb finds compact galaxies at very early times, it is not only discovering distant objects, it is potentially illuminating the origin story of density itself in later galactic populations. And that story did not begin with Webb from nothing. Even before Webb, astronomers already knew that many massive galaxies in the earlier universe, though not quite as early as the first few 100 million years, were surprisingly compact compared with similar mass galaxies today. That older result had already suggested that some galaxies built dense stellar cores early, and then changed size later through mergers, accretion, and structural evolution. Webb pushes that theme deeper into time. It does not introduce the idea that compact galaxies can exist. It reveals that the roots of compactness and fast assembly may reach even closer to the beginning than we had been able to study clearly before. This continuity matters because it keeps the story from becoming isolated. The early compact galaxies are not just weird remote exceptions. They may belong to a larger evolutionary chain. The dense systems seen a few billion years after the Big Bang, the massive compact galaxies known from earlier surveys, the central bulges of later galaxies, the structural fossils in the nearby universe. All of these may be connected through a long history in which concentrated beginnings are repeatedly important. And yet the earliest examples still feel distinct. They are operating under a pressure that later systems inherited only indirectly. That is why the first billion years retain their special grip on the imagination. We are seeing not just compactness, but primordial compactness. Compactness before the universe had settled into anything we would call ordinary. Compactness, while the cosmic background was still hotter, while reionization was still unfolding, while galaxies themselves were helping transform the wider medium between them. The earliest dense systems were not growing in a finished universe. They were growing while the universe was still becoming transparent to certain kinds of light, while the largest structures were still assembling, while the relationship between galaxies and intergalactic gas was especially raw. The environment was unfinished. The local consequences were not. That contrast is part of what gives the whole subject its eerie calm. From far away, cosmic dawn sounds soft. Up close, it may have been one of the most physically demanding periods in the history of structure formation. Matter had opportunities then that later epochs no longer offered in the same way. Higher densities, more readily available inflows in some regions, rapid hierarchical build-up, fewer settled boundaries between system and environment. A compact galaxy born into that world could be both fragile and ferocious, small in extent and huge in implication. It also changes how we think about maturity. The word is dangerous because it invites a false binary. Either a galaxy is young and primitive, or mature and modern. The real universe does not honor that neat split. A galaxy can be young in absolute age, and still mature in a limited structural sense. It can possess a compact core, complex star-forming regions, enriched gas, or even a temporarily reduced star formation rate without being a fully settled modern galaxy. Webb's compact objects keep pushing us toward that more precise understanding. Maturity is not all or nothing. It can emerge in pieces. A core can mature before the outskirts exist. A burst can chemically age a region before the galaxy as a whole relaxes. A local structure can become sophisticated while the wider system remains turbulent. Once you allow that, the early universe stops looking like a timeline of clean stages and starts looking like overlapping modes of development. This part of a galaxy is ahead. That part is still assembling. One component is concentrated, another is diffuse. A central region may already be dense enough to influence the rest disproportionately. All of which makes the compact galaxy story less about surprise and more about legibility. Webb is making the unevenness of early growth visible. And uneven growth has consequences for everything that comes after. Because once some regions race ahead, they begin setting the terms for future evolution. A dense core can alter gas dynamics. Early feedback can regulate later star formation. Mergers can build on pre-existing compact structures rather than starting from smooth distributions. The future galaxy inherits not a blank past, but a shaped one, which means that when we look at compact galaxies near the dawn of cosmic time, we may not just be witnessing one odd phase. We may be seeing the first hard choices matter made about how later galaxies would be built. That thought carries us naturally toward another layer of the story, one that makes the compactness feel even more vivid. Because if these galaxies were already this concentrated, and already this dynamically self-altering, then what was it like to inhabit the larger universe around them? Not as an astronomer reading a graph, but as matter itself, as gas caught between infall and radiation, as a cosmos in which the first bright structures were beginning to punch their influence into the darkness. To imagine that, we have to leave behind the clean, silent pictures produced for us on screens. The real early universe was not made of isolated cutouts floating in black perfection. It was a medium. Gas filled the vast spaces between galaxies. Radiation moved through it unevenly. Some regions stayed neutral longer, still holding on to electrons and protons as separate possibilities not yet fully forced apart by pervasive energetic light. Other regions, around active young galaxies, began changing state. The first luminous structures did not merely appear inside darkness. They began working on the darkness. That wider transformation matters because compact galaxies were not forming in private. They were participating in one of the largest environmental shifts in cosmic history. The period is often described in technical terms as reionization, but what matters most for the feeling of it is simpler. The universe after its first stars and galaxies was not just turning on lights. It was altering the condition of the space between those lights. Energetic photons from young stars escaped into the surrounding medium and began ionizing hydrogen across growing bubbles of influence. Those bubbles expanded, overlapped, and slowly changed the cosmic environment on large scales. So when we talk about compact early galaxies, we're not only talking about internal structure, we're talking about engines capable of affecting their surroundings in a universe still unusually responsive to local sources. A compact galaxy in that context becomes more than a dense knot of stars. It becomes a pressure point in a transforming cosmos. You can think of it like sparks in a dry landscape, except with one important difference. This is not a story of destruction, but of alteration. The first bright galaxies were carving zones of change physics into the intergalactic medium around them. The more concentrated and energetically active some of those galaxies were, the more important they become in that larger process. Their compactness may have helped create conditions for intense radiation fields. Their starbursts may have increased the supply of ionizing photons. Their feedback may have opened channels through which radiation escaped more effectively. These details are still being worked out, but the basic picture is powerful. The first concentrated systems were not simply witnesses of cosmic dawn, they were among its authors. That changes the emotional scale of the subject. A strangely compact galaxy is suddenly not just a small object far away. It is a local machine with environmental reach. Small in size, yes, but with consequences extending far beyond its own visible boundary. It might sit in a halo only a fraction of the scale of later giant galaxies and still influence the state of gas across much larger distances. In ordinary life, we often equate size with power. Webb keeps reminding us that in the early universe, concentration itself could be a form of power. And concentration always comes with trade-offs. The same intense star formation that makes a compact galaxy bright may also make it unstable. The same clustered energy that allows it to punch above its size may help disrupt its future fuel supply. The same dense environment that supports rapid growth may also accelerate turbulence, gas heating, and local exhaustion. So the story is not one of simple triumph. It is more like the story of a system trying to outrun its own consequences. Some may have succeeded for a long time. Some may have burned through favorable conditions quickly. Some may have grown by merging with others, becoming part of larger structures that preserved only traces of their original compact lives. This is why the compact galaxies feel so humanly legible despite their scale. They are caught between opportunity and cost. A crowded city grows fast because everything is close together. Ideas, labor, trade, pressure, conflict, invention, exhaustion. Density creates possibilities. It also creates strain. The early galaxies Webb sees may have lived under a cosmic version of that logic. Their compactness is not merely a visual property. It is a statement about proximity. Matter close to matter. Energy close to fuel. Consequences close to causes. And when causes and consequences move that close together, history speeds up. That may be the most important sentence in the whole story. History speeds up, not everywhere equally, not forever, but in the regions Webb is now making visible. The universe seems to have allowed pockets of rapid change that make our inherited mental picture of the first galaxies feel far too slow. We imagined a gentle ramp. In some places, it may have been more like a compressed staircase, climbed 2 or 3 steps at a time. The observational evidence for that speed comes from different directions at once. Sizes are small, brightness can be high, emission lines are strong. In some systems, chemical enrichment appears to have happened early. A few show hints of internal differentiation. A few may already have passed through a brief decline in star formation. Some crowded sources resolve into mergers, which softens one headline while strengthening the idea of active, dense assembly. The point is not any one clue by itself. The point is the convergence. Convergence is what turns surprise into understanding. If only the sizes were odd, we might blame measurement. If only the brightnesses were high, we might blame temporary bursts. If only the morphologies looked complex, we might blame interpretation. But when compactness, activity, environment, and timing all lean in the same direction, the early universe begins speaking with a more coherent voice. It says that local structure formation could proceed with real urgency. It says that some galaxies became concentrated centers of work very quickly. And it says that the deep past was not simply emptier than the present. In some ways, it was more crowded where it counted. There is a beautiful inversion hidden inside that. We are latecomers living in a more expanded universe. On the larger scales, galaxies are farther apart than they were then. The cosmos around us is older, colder, more diluted. We inhabit a time of long aftermaths. Yet when we look back far enough, into what sounds like the beginning, we find places that seem more pressurized than the calm sky above us suggests. The ancient universe was not more relaxed because it was younger. In many local environments, it was harsher, tighter, and more reactive. That is one reason Webb's observations have such emotional force even when stripped of all sensationalism. They do not merely add information, they correct atmosphere. They make the early universe feel denser in the mind, less like a smooth prologue, more like a period already full of bottlenecks, crowded lanes of inflow, hard radiation, chemical work, and structural experiments happening in compressed volumes. They remind us that the first recognizable galaxies were not waiting around to become consequential. They already were. Of course, there is still so much we do not know. We do not know the full life stories of most of these objects. We do not know how representative every famous compact galaxy will prove to be as samples grow. We do not know, in every case, how much of the apparent concentration belongs to stars, ionized gas, mergers, or hidden outskirts. We do not know how often early compact systems became the seeds of later bulges, how often they were disrupted, or how often they passed through multiple active and quiet phases. But uncertainty here has a very different flavor from ignorance. It is no longer the uncertainty of emptiness, it is the uncertainty of abundance. There is already too much happening to fit inside the old picture, and when that happens in science, it is a sign of progress. The first galaxies are not fading into simplification as we observe them more clearly. They are becoming more numerous, more diverse, more specific, more physically demanding. The mystery is no longer, did anything substantial exist that early? The mystery is becoming, how many different kinds of substantial activity were already underway, and how fast could the early universe force matter into concentrated, self-altering forms? Once that question takes hold, it becomes difficult to return to the sky above us in the same way, because the stars no longer sit over a blank ancestral darkness. Behind them lies an era when some of the first galaxies were already crowded enough to bend their own futures, bright enough to alter their surroundings, and compact enough to reveal that the beginning was not simple. It was compressed. And the deeper we go into that compression, the more another thought begins to rise. Maybe the strangest part is not that these galaxies were small, but that they were already becoming complicated before the universe had even learned how to be old. That is the part that lingers, not simply the size, but the mismatch between age and complexity. We are used to reading age as a universal guide. A young forest has saplings, a young city has scaffolding, a young language has not yet layered itself with centuries of drift. So when the universe itself was only a few 100 million years into its history, we expected its galaxies to be correspondingly plain, not non-existent, just plain. Webb has been teaching us, gently but firmly, that this expectation confuses chronology with condition. A thing can be early in absolute time and still locally advanced if the forces acting on it are strong enough and concentrated enough. That correction reaches beyond astronomy because it touches one of our deepest habits of thought. We prefer smooth developmental stories. We prefer beginnings that look unmistakably like beginnings. They are comforting. They preserve order in the imagination. But nature often grows by local excess. Pressure gathers unevenly. Some regions race ahead. Some structures emerge under strain. Some systems look older than their calendar because they have lived harder inside the time available to them. The compact galaxies Webb sees belong to that family of realities. They are reminders that development is not always graceful and not always evenly distributed. In the early universe, there were places where gravity and gas seemed to have made use of time with startling efficiency. Places where light became concentrated quickly. Places where stars formed in compressed quarters. Places where chemistry advanced, feedback intensified, and structure became legible before the broader human picture of cosmic dawn had even caught up. A useful way to hold that in the mind is to imagine not one universe-wide clock, but millions of local clocks running under different pressures. The global clock says the universe is young. The local clock inside a dense halo says gas is falling in now. Stars are forming now. Radiation is reshaping the environment now. A compact galaxy may therefore be globally young and locally intense. Young by the calendar, but already deep into consequences. That is the paradox Webb keeps making visible. And once it is visible, another old assumption starts to loosen. We often imagine scale and complexity growing together. Small things are simple, large things become elaborate. Yet the early compact galaxies show that a relatively small physical system can host astonishing richness. Not just stars, but gradients, clumps, central concentrations, outflows, obscuration, interaction, and possibly even the first hints of decline. Complexity does not always wait for expansion. Sometimes it emerges under compression. That is why these objects feel less like early sketches and more like compressed manuscripts, not complete, not final, but already dense with revisions, tensions, and layers. There is a scientific consequence to that idea. If complexity can emerge this early, then the models we build for galaxy formation have to be sensitive not only to average growth, but to tail behavior, to the systems that, under favorable conditions, move much faster than the median. A model can get the broad cosmic population roughly right, and still miss something crucial if it underestimates how quickly some rare or semi-rare environments can assemble stars, build central densities, or interact with their surroundings. That is one reason Webb's compact galaxies matter so much to theorists. They test the pace limits of formation. How fast can a galaxy become itself? That is not a poetic question. It is a physical one. How rapidly can a dark matter halo gather enough gas? How efficiently can that gas cool? How much can turbulence delay collapse? And when does it instead contribute to fragmentation and rapid star formation? How often do mergers accelerate concentration rather than simply adding mass? How quickly can stellar feedback regulate the process without shutting it off completely? At what point does dust become a serious player in systems this early? Every compact galaxy pushes on these questions because it occupies the place where timescale becomes visible. And visibility is the crucial word. The universe may always have been doing some version of this. What changed with Webb is that we can see enough of it to feel the challenge. Before this era of observation, it was easy for the earliest galaxies to remain abstract placeholders in a narrative. First stars, first galaxies, reionization, then more recognizable structure later. Those labels are still useful, but they hide too much. Webb has begun replacing placeholders with environments. A compact source is not an item in a timeline. It is a place with density, with internal competition, with a biography implied by its light. Some biographies are still hard to read. Some turn out to be less dramatic than first reported, but even the moderated versions are richer than what came before. That is part of why the story has held public attention without needing cheap exaggeration. The real thing is already enough. A galaxy so distant that its light has travelled for more than 13 billion years should, by older intuition, feel almost too primitive to matter beyond its existence. Instead, some of these galaxies look active enough, concentrated enough, and in certain cases differentiated enough to force a deeper thought. By the time their light left them, they were already in the middle of something. The middle of something, that phrase changes the emotional balance. It means we're not only looking at origins, we are looking at processes already underway. Some galaxies are not arriving to us in their first breath, but mid-effort, mid-assembly, mid-starburst, mid-interaction. Perhaps, in rare cases, mid-recovery from their own early intensity. And because the light is delayed, every observation becomes strangely double. We are seeing something ancient, but we're seeing it at a moment when it was living through an urgent present of its own. There is tenderness in that. A galaxy can be unimaginably far away and still not feel remote in meaning. It was busy. It was changing. It was already becoming more than the word first suggests. This is also where the title's emotional power fully opens. Strangely compact sounds at first like a narrow technical curiosity, the sort of detail only specialists would care about. But compactness is the doorway through which all of this comes into view. Compactness leads to density. Density leads to intensity. Intensity leads to feedback. Feedback leads to accelerated local history. accelerated history leads to the unsettling recognition that the early universe may have contained not only beginnings, but compressed biographies. And that recognition changes the sky. It changes it because the night above us starts to feel less like a ceiling over peaceful ancestry, and more like a thin final layer above an earlier era of concentrated work. We live in a universe that has had time to spread out, time to cool, time to dilute, time for many galaxies to become larger, quieter, or at least more spacious in their expression. When Webb looks back, it is not seeing a smaller version of today. It is seeing a different regime, an era in which the same basic ingredients, gravity, gas, radiation, dark matter, were combining under conditions that made some local outcomes far more compressed than our daily intuition prepared us for. The result is not a universe that becomes less understandable as we learn more. It becomes more specific, and specificity is one of the deepest forms of wonder. A vague mystery can impress you once. A specific mystery can stay with you. It can keep unfolding because it has texture. The compact galaxies are specific in that way. Their sizes matter. Their brightness profiles matter. Their spectral signatures matter. Their environments matter. Their ambiguity matters too, because it forces careful reading instead of theatrical certainty. These are not props for cosmic awe. They are difficult, luminous facts pulling us toward a more honest image of the first billion years. And the more honest image is, in some ways, more emotional than the softened one, because a soft beginning can leave us detached. It lets us treat the early universe as a polite prelude. A compressed beginning does something else. It lets us feel that reality was already under pressure before almost anything we would call familiar had appeared, that there were already crowded hubs of activity while the cosmos itself was still very young, that there were already local histories being written into light, and that consciousness, much later, on one small planet, has somehow become capable of receiving those signals and noticing that the first darkness was not empty after all. It already had neighborhoods. Some of them were bright, some were dusty, some were colliding, some were compact enough to raise eyebrows and force models to sharpen, some may have briefly exhausted themselves, some may have become the cause of the later galaxies or vanished into mergers and transformation, but they were there, and they were doing real work early. That is the fact Webb has made much harder to ignore. By now, the obvious temptation is to ask whether this makes the universe more alien or more familiar. The answer, strangely, is both. Alien because the pressures, scales, and timescales are so unlike anything the body knows. Familiar because concentration, feedback, acceleration, and uneven development are patterns we recognize everywhere once we know how to look. The early universe was not human, of course, but it was not emotionally illegible. It knew what dense systems often know. When too much happens in too little room, the future arrives quickly, and that may be the deepest truth hiding inside these distant, strangely compact galaxies. Not only that the beginning was more crowded than we imagined, but that crowded beginnings have consequences that echo for billions of years, which means the next thing to ask is not just what these galaxies were, but what they became, and whether some part of their compressed lives still survives, quietly buried inside the larger, older galaxies that fill the universe now. If they do survive, they probably do not survive in a clean, labelled way. The universe is not an archive with tidy folders. It is a place where structures merge, expand, disturb one another, hide inside later layers, and keep moving long after their original conditions have disappeared. So when we ask what became of these compact early galaxies, we are really asking a more subtle question. Can an early pressure regime leave a lasting fingerprint inside later, larger systems? Can the universe carry forward the memory of compression? There are good reasons to think it can. A dense central stellar concentration does not simply vanish because the galaxy around it grows. Later accretion can wrap new material around it. Mergers can stir it, distort it, partially bury it. Star formation can continue in the outskirts while the original core remains as a compact record of an earlier phase. Over billions of years, the visible result may look much broader and calmer, but buried inside that larger body there may still be a fossil of the period when matter was gathered under more urgent conditions. In that sense, some compact early galaxies may not be oddities stranded in the distant past. They may be ancestors with descendants all around us. That possibility creates a bridge between the deep sky and the nearby one. It means the story Webb is telling is not just about remote objects that no longer matter. It may be about the opening moves of galactic architecture that continue to shape later history. The central bulges of big galaxies, the dense inner regions of ellipticals, the compact remnants preserved inside more extended systems. All of these become more interesting when you realize that their lineage may run back to a time when the universe itself was much tighter, and some galaxies were learning density before they learned spaciousness. You can feel how different that is from the old simplified picture. Instead of imagining galaxy evolution as a smooth, uniform inflation from primitive to mature, we begin to see it more like layered construction. Some galaxies may have built a dense core early, then change by adding looser outer structure later. Others may have grown through repeated mergers, preserving pieces of their compact past while scrambling the details. Others may have burned brightly and then been absorbed into larger systems whose final appearance hides the violence of their beginnings. Growth, in other words, does not erase early compression. It may incorporate it. This is one of the reasons astronomers care so much about size evolution across cosmic time. A galaxy's dimensions are not merely descriptive, they are historical. If galaxies of a given mass tend to be more compact earlier in the universe and more extended later, then the obvious question is why? Are stars forming farther out as time goes on? Are dry mergers puffing systems up without reigniting star formation? Are dense early cores acting as seeds that later history wraps in softer, larger envelopes? The answer is probably not one thing, but the broad implication is clear. Size is part of biography. And Webb has moved that biography closer to the beginning. That is what makes these early compact galaxies feel so alive as a subject. We are not just learning that a few ancient systems were small. We are catching the universe in the act of writing some of the earliest pages of galactic memory, a compact core, a burst of star formation, an interaction in a crowded environment, an episode of rapid enrichment. These may not remain visible in simple form, but they can leave structural consequences. Later galaxies may be calmer not because they were always calm, but because they carry the settled remains of a harsher opening. There is something almost geological about that. A mountain looks still, but its stillness contains old collisions. A river valley looks peaceful, but its shape records pressure, erosion, force, and time. Galaxies may be like that too. The mature forms we see nearby can contain old dynamical weather compressed into their inner structure. Webb is helping us read the weather near the time it happened. That reading matters because it changes the emotional meaning of the present universe. The galaxies around us are not simply final forms. They are layered outcomes, the calm disk of the Milky Way, the smooth light of an elliptical, the dense center of a massive system. None of these are innocent shapes. They are the current arrangement of a much longer struggle involving collapse, inflow, star formation, feedback, interaction, and the gradual negotiation between concentration and spread. When Webb looks back and finds galaxies already oddly compact, it is giving us a glimpse of one of the early terms of that negotiation. And there is no guarantee the negotiation was gentle. A compact core can be a sign of success, but also of cost. Dense early star formation can build stellar mass quickly, yet it can also consume gas, heat the surrounding medium, and trigger feedback that changes everything that comes next. A merger can increase central concentration while disrupting order. A brief outburst can create the appearance of rapid maturity while setting up the conditions for a temporary lull. This is why compactness is such a fertile clue. It points to a place where several major processes meet: assembly, intensity, instability, memory. The more you sit with that, the less these galaxies feel like exceptions and the more they feel like crossroads. They sit at the intersection of a few deep truths about the universe. Gravity loves concentration. Radiation resists it. Growth creates the conditions that later restrain growth. Local environments matter, and the beginning of a system can remain legible inside its mature form long after the original pressure has passed. A strangely compact galaxy is where all of those truths become visible at once. This is also where the emotional tone of the story begins to change. Up to now, compactness has carried some unease, some surprise, some quiet shock. But if these objects are also ancestral, then another feeling enters: intimacy. The distant universe becomes less remote when you realize that its compressed experiments may still echo in the structure of galaxies much closer to us. We are not only looking at strange old things, we may be looking at family history. Not family in any sentimental sense, family in the physical sense of descent, inheritance, and carried forward form. A compact early galaxy may vanish as an individual object, but its stars can survive inside a later merger product. Its dense central region may become the nucleus of a larger descendant. Its chemical work may enrich later generations. Its feedback may alter the path of gas that would otherwise have formed a different galaxy altogether. In that way, the compactness Webb observes is not sealed in the past. It participates in the making of the future. And that future includes us, at least indirectly. Not because there is a straight, romantic line from one distant compact galaxy to human life. The universe is too large and too contingent for that kind of tidy storytelling. But because the general processes that shaped galaxies also shaped the cosmic context in which stars like the Sun and planets like Earth could later emerge. The spread of heavier elements, the structuring of galactic environments, the evolution of the cosmic web, the rise and fall of dense star-forming systems, all of it belongs to the long chain of conditions that made a habitable world possible billions of years later. The compact early galaxies are part of that larger unfolding. That realization does something subtle to the word early. It stops sounding like before anything relevant. It starts sounding like while essential things were already being decided. And many of those decisions were decisions about concentration, where matter gathered, how efficiently it cooled, how tightly light was packed, how quickly a core could form, how fast feedback arrived, whether a galaxy's first major act was expansion, collision, or compression. In the beginning, not everything was settled, but a great deal was already at stake. Webb's compact galaxies make that difficult to forget. By now, though, a final tension has become impossible to avoid. If these early systems may be ancestral, and if their compactness may be both a clue and a memory, then how should we hold the balance between caution and revelation? How do we avoid cheap conclusions without draining the wonder out of what Webb is actually showing us? Because this subject is constantly pulled between two temptations, the temptation to overstate and the temptation to flatten. The truth lives somewhere more demanding than either one. That middle ground is where the real power is. Overstatement is easy. You take every compact galaxy, every bright early source, every puzzling measurement, and turn it into a slogan about everything being wrong. It feels dramatic for a moment, but it cheapens the subject. Flattening is easy too. You say the data are complicated, interpretations vary, models will adjust, nothing to see here. That sounds sober, but it drains the life out of the evidence. The stronger path is harder because it asks us to remain precise without becoming cold, and open to surprise without becoming reckless. Webb deserves that stronger path, because what it has revealed is not ordinary. Some early galaxies really do appear physically concentrated in ways that force a correction to the public imagination of cosmic dawn. Some seem remarkably bright for their age. Some show evidence of intense star formation. Some may already be chemically enriched beyond the naive expectation for such an early epoch. Some look internally differentiated in ways that hint at compact cores or organized components. Some famous anomalies become more understandable when resolved into mergers or crowded systems. Yet the broader pattern of rapid early assembly remains, and a few may even point toward shortened or interrupted star formation histories shockingly early in cosmic time. None of that requires the universe to become unintelligible. It requires us to let it become less simplified. That distinction matters far beyond this one subject. It is the difference between science as theatre and science as encounter. Theatre wants one decisive emotional note. Encounter asks you to let reality keep its texture. A strangely compact galaxy is not an argument for chaos in our understanding. It is an argument that understanding improves when we allow for denser, faster, more uneven growth than the old softened picture allowed. The universe is still readable. It is just speaking in a sharper accent than we expected. And there is something deeply satisfying about that. Because it means the reward of better observation is not merely more information. It is better contact with what the universe was actually like. Contact with the fact that early does not mean simple. Contact with the fact that local conditions can make history run faster. Contact with the fact that small physical size can coexist with enormous astrophysical consequence. Contact with the fact that a galaxy's light profile can become a doorway into the pressures under which it lived. This is why the compactness story matters, even if some individual claims soften over time. The central revelation survives that softening. The first billion years were not a blank prelude. They contained environments where matter organized itself with startling urgency. Some galaxies became tight knots of activity. Some occupied crowded regions. Some may have cycled through intensity and restraint before the universe was what we would emotionally call old. The details will continue evolving. The atmosphere of the era has already changed. An atmosphere is not a trivial thing to change. It changes what questions become natural. Once the early universe feels denser in the mind, you stop asking only whether the first galaxies existed. You start asking how they lived, how they fed, how they pushed back against their own growth, how they influenced the gas around them, how much of their compactness was structural, how much phase-dependent, how much shaped by interaction, whether dense early cores became the seeds of later galactic centers, whether some galaxies raced ahead while others remained faint and diffuse, whether our own late-time spaciousness is not the default form of a galaxy, but the result of billions of years of subsequent rearrangement. Those are richer questions because they are closer to the physical truth. They also make the universe feel more humanly intelligible in a paradoxical way. Not familiar in scale, never that, but familiar in pattern. Under pressure, systems differentiate. Under concentration, consequences arrive faster. Growth can intensify the very forces that later restrain growth. Brightness can coexist with instability. Early phases can leave marks that much later phases still carry. These are not human truths exactly, but they are truths we recognize once they are translated carefully enough. That is why Webb's compact galaxies do not remain abstract if you sit with them long enough. They become legible as dense systems living under urgent conditions. There is one more subtle correction hidden here, and it may be the quietest important one of all. The first galaxies were not merely objects to be found, they were conditions to be entered imaginatively. A catalogue tells you they exist, an image tells you they are bright, a size measurement tells you they are concentrated. But only when you pull those threads together do you begin to feel what their world was like. The compressed light, the strong emission, the likely bursts, the possible mergers, the surrounding medium still being altered, the risk of rapid feedback, the chance that some systems already brushed against temporary exhaustion. All of that gives the early universe weather. It gives it pressure. It makes it feel less like an origin myth and more like a place. And once the distant past becomes a place, your relationship to it changes. It is no longer enough to say that the first galaxies appeared. Appearance is too passive a word. Some of them seem to have surged into being under conditions that gave them immediate consequence. They did not just take up space. They worked on their environment. They converted gas into stars, stars into radiation, radiation into altered cosmic surroundings. They may have built dense regions that later galactic evolution would preserve or wrap in newer layers. They may have created central structures early enough to challenge our intuition without violating the broader physical laws that made them possible. That balance is worth protecting. Surprise without fantasy, compression without melodrama, evidence with room to breathe. It is also worth noticing how much emotional maturity the subject asks of us. The childish response to an anomaly is either triumph or dismissal. Either everything changes or nothing does. Webb's compact galaxies ask for something more adult. They ask us to stay in the middle long enough for a stronger understanding to form. Yes, some claims will be moderated. Yes, some first impressions will sharpen into more complex pictures involving dust, hidden outskirts, interactions, or selection effects. But if, after all of that, the early universe still emerges as a place where a notable population of galaxies were compact, active, and unexpectedly consequential, then that is not a weakened result. That is a durable one. A durable result changes imagination more deeply than a dramatic one. It stays. It works on you slowly. The night sky becomes harder to treat as calm inheritance. The word early becomes harder to confuse with simple. The first billion years stop feeling like a soft entrance hall and start feeling like a compressed age of rapid experiments in density, light, and structure. And perhaps most strangely, Galaxies that appear small in the images begin to feel larger in significance than many giant nearby systems, because they reveal the regime in which later galactic history may have learned some of its most enduring habits. That is when the title promise fully pays off. Strangely compact is no longer a curiosity at the level of shape. It becomes a summary of a deeper cosmic truth. The early universe allowed matter to become concentrated enough, quickly enough, that whole local histories could unfold in spaces far tighter than late-time intuition would expect. Those galaxies are strange not because they are impossible, but because they expose how misleading our preferred mental image of the beginning really was. And that mental image may be the final thing Webb is compressing. It is taking a distant, vague epoch and forcing it into clarity, forcing us to admit that what we called cosmic dawn was already crowded with structure, already bright in places, already chemically active, already vulnerable to feedback, already capable, in at least some cases, of creating galaxies whose light arrives not as a soft announcement of origin, but as evidence of a system already deep into consequences. That is a very different dawn from the one most people imagined. By the time the light reached us, the work was already underway. By the time we learned how to read it, the universe had already spent billions of years moving on. And still, somehow, the signal remains. It crosses expansion, darkness, instrumentation, skepticism, and interpretation, and it still tells the same essential story. In the beginning. Not every galaxy was a loose rehearsal. Some were tight with purpose, tight with fuel, tight with pressure, tight enough that their own futures may have arrived early. Which means the last thing to understand is also the simplest and the hardest. What it does to us, here and now, to realize that the ancient universe was not merely far away, but already astonishingly busy before almost anything familiar had begun. What it does, if we let it, is make ordinary perception feel slightly less trustworthy and much more precious. Less trustworthy because daily life trains us to read calm surfaces as simple histories. A quiet neighborhood seems as though it must have grown quietly. A mature tree seems as though it must have had an uncomplicated beginning. The night sky, especially, tempts us into that mistake. It looks serene. The stars hold their positions. The dark between them seems empty enough to absorb thought without arguing back. But Webb has become one of the instruments by which the universe argues back. It has shown us that serenity is often a late condition, not an original one. That what appears spacious may be the aftermath of things that were once compressed. That a calm sky can be covering an ancestry of crowded beginnings. More precious because we can now witness that correction at all. There is something deeply unlikely about this. A species on one small world, orbiting an ordinary star in a late-generation galaxy, built a telescope cold enough and sharp enough to receive light from a period when galaxies were only beginning to exist. Not only receive it, but distinguish enough detail to realize that some of those first systems were already surprisingly concentrated. We are not close to those galaxies. We cannot touch them. We cannot visit them. And yet we have become able to notice that, in certain corners of the early cosmos, matter had already learned how to gather itself with unsettling speed. That is not just information. It is contact. A very thin kind of contact, delayed by more than 13 billion years and mediated by mirrors, detectors, models, and mathematics. But contact all the same. Contact with a reality that did not need us in order to happen, yet now enters human awareness. If that sounds abstract, bring it back down to the simplest image. A compact early galaxy is a small, bright concentration of ancient light. We study its profile. We infer its size, we estimate its star formation. We wonder about its dust, its environment, its companions, its future. Through all of that technical work, something very old becomes almost physically imaginable. Not close, not familiar, but imaginable enough that the beginning of galactic life stops being a blank category and starts becoming a place with pressure in it. Pressure is the word that keeps surviving every layer of the story. Pressure of gravity pulling gas inward, pressure of density accelerating interaction, pressure of radiation and stellar winds pushing back, pressure of interpretation, because the data ask us to remain careful without becoming timid, pressure on our old picture of cosmic dawn, which now looks too soft, pressure even on language, because words like young, primitive, and early no longer behave the way they used to once compact galaxies enter the frame. Maybe that is why the subject stays with people who encounter it seriously. It is not just surprising, it reorganizes intuition. After a while, you stop hearing only 500 million years after the Big Bang, as if it means almost nothing had happened. You start hearing it as a challenge. Under those conditions, what could happen in 500 million years? The answer Webb keeps suggesting is more than we felt in our bones was possible. Enough for some galaxies to become dense in light. Enough for some to experience violent star formation. Enough for some to enrich themselves. Perhaps interact. Perhaps begin building cores. Perhaps even edge into temporary quiet. Enough for the early universe to stop feeling like rehearsal and start feeling like a compressed age of real consequences. And when a period of time starts feeling real, it also starts feeling inhabited. Not inhabited by people, of course. Inhabited by processes, inhabited by tensions, inhabited by matter under stress. That matters emotionally, because it rescues the distant past from abstraction. One reason the first galaxies used to remain conceptually thin in the public imagination is that they were too easy to summarize. First stars, first light, first galaxies. Those labels are useful, but they smooth away the local weather. Webb's compact galaxies give some of that weather back. They suggest regions where the atmosphere of cosmic history was already thick, not with air, but with inflow, feedback, radiation, and structural consequence. There is a kind of tenderness in realizing that the universe became complicated so early. Not sentimental tenderness, something quieter. The tenderness of discovering that reality did not wait for us to be ready before becoming intricate. That long before Earth existed, long before the sun, long before any creature looked up and wondered, there were already little crowded systems in the dark running through hard versions of growth, gathering, igniting, altering their surroundings, living through conditions that, if translated badly, sound like sterile astrophysics, but if translated honestly, feel more like compressed existence. And compressed existence always leaves marks. That may be the final practical reason these galaxies matter. They are not just telling us about one era, they help explain why the later universe looks the way it does. If some galaxies built dense cores early, later structures had to grow around those cores. If early feedback regulated star formation, later growth inherited that regulation. If compact systems merged, their descendants carried the memory of those mergers in altered form. If some early galaxies went through bursty cycles, later populations reflect that unevenness in ways that smoother models would miss. The first billion years were not a disposable beginning, they were a foundation with specific pressure patterns impressed into it. So when we speak about compact galaxies near cosmic dawn, we are not only speaking about a visual anomaly, we are speaking about the opening pressures of galaxy history made briefly visible. That is why the subject feels larger than its phrasing. Strangely compact sounds modest, almost niche, but hidden inside it is an enormous correction. The deep past was not merely dimmer, in places it was denser, not merely younger. In places, it was already more internally consequential than later intuition would guess, not merely beginning, in some corners, already becoming difficult. Difficult is a good word for reality when we meet it honestly. Not hostile, not obscure for its own sake. Difficult because it resists the tidy forms we prefer. Difficult because it asks for more careful imagination. Difficult because it does not reward us with one clean interpretation and a neat emotional ending. Webb's compact galaxies remain difficult in exactly that good way. We still need better data, larger samples, more refined models, better ways of distinguishing bright clumps from full structure, clearer connections between observed light and total mass, stronger understanding of dust and burstiness and environment. All of that work remains. Yet the work is now being done in a universe that has already revealed more than the old picture could comfortably contain. There is relief in that too, because it means mystery is not emptiness, it is density beyond our first reading. A blurry mystery says, "You cannot know enough yet." A sharp mystery says, "You know enough now to realize the world is richer than your old summary." Webb has been giving us the second kind. The compact galaxies are part of that gift. They do not erase uncertainty, they upgrade it. They turn it from ignorance into textured contact. And that textured contact changes the meaning of distance. A galaxy whose light began its journey when the universe was only a few 100 million years old should, by all ordinary habits of feeling, remain remote in every sense. But once you know that some of those galaxies were already dense with action, already gathered into concentrated forms, already participating in the transformation of the wider medium around them, remoteness becomes a strange category. They are far in space, they are far in time. Yet the conditions they reveal, pressure, concentration, acceleration, feedback, uneven development, are not alien to thought once we have names for them. We cannot live those scales, but we can understand their logic. And understanding, when it is real, reduces a certain kind of loneliness. Perhaps that is one of the hidden emotional payoffs of astronomy at its best. Not that it makes the universe smaller, but that it makes it less indifferent to the mind. Not because the universe cares, but because it can be met. Its oldest light can still arrive carrying structure. Its structure can still be interpreted. And that interpretation can still widen feeling rather than replacing feeling. So when we look back at these compact early galaxies, we're doing more than solving a technical puzzle about half-light radii and star formation densities. We're revising one of the oldest myths we carried without noticing, the myth that the beginning must have been simple. Webb has made that harder to believe. The beginning, at least in some places, was already crowded with architecture, already thick with consequences, already full of local histories running faster than the global age of the universe seemed to allow. And once that truth enters the mind, even gently, it does not leave quietly. It stays there and starts changing the scale of ordinary things. A city at night looks different once you have thought seriously about density. Not just how many lights there are, but how much life is packed behind them, how many decisions, frictions, routines, and collisions are compressed into a narrow geometry. A body feels different once you have thought about feedback. A system that responds to its own behavior while the behavior is still happening. A timeline feels different once you have thought about local clocks. The same span of years containing radically different amounts of live change depending on pressure, supply, and constraint. Webb's compact galaxies do that to the cosmos. They make the early universe harder to treat as a smooth backdrop, and easier to understand as a place where concentrated histories could unfold inside very small volumes of space. That shift does not need loud language to be profound. In fact, the quieter you hold it, the stronger it becomes, because the evidence itself is already enough. We have ancient galaxies whose light comes from the first few 100 million years. We have measurements suggesting that some of them are remarkably concentrated. We have signs of intense star formation, strong emission, and in some cases rapid chemical processing. We have indications that not every compact appearance means the same thing. Some systems are intrinsically dense, some are boosted by bursty episodes, some are shaped by mergers, some may hide faint outskirts, some may already have moved into a quieter interval after an intense beginning. Put together, these do not give us one slogan, they give us a revised atmosphere of cosmic dawn. And atmosphere may be the deepest thing science changes. Facts matter, always, but facts do more than stack. They alter what it feels like to think inside a subject. Before Webb, many people could say all the right words about early galaxies and still picture them vaguely, softly, almost symbolically. After Webb, that becomes harder. The first galaxies no longer feel like placeholders. They feel like systems under load. They feel like concentrated negotiations between gravity and energy. They feel like places where enough had already happened for compactness to become meaningful. Enough for some galaxies to start carrying not just light, but history. History in the strongest sense. Not mere age, not just duration. History as accumulated consequence. A compact early galaxy has history because something had to occur in order for light to pile up that way. Gas had to collect, cooling had to proceed, stars had to form, radiation had to flood the nearby medium, heavy elements may already have begun to circulate. Perhaps interactions had already distorted the scene. Perhaps feedback had already started limiting what came next. All of that is history. And all of it lived inside a universe that, on the larger scale, was still astonishingly young. There is a line hidden in that contradiction that keeps returning. Young is not the opposite of eventful. The first time that sentence really settles, the title pays off in a much larger way. The galaxies appear strangely compact because our intuition about young things was wrong. We expected spacious immaturity and found compressed significance. We expected the beginning to announce itself as simplicity and found that, in at least some places, the beginning had already become demanding, not finished, not settled, but demanding. Demanding of theory, demanding of observation, demanding of language itself. Language is worth pausing on for a moment, because astronomy often fails in public not through bad facts, but through tired metaphors. We hear cosmic dawn and imagine softness. We hear infant universe and imagine helplessness. We hear first galaxies and imagine prototypes. Those phrases are not useless, but they are incomplete in a way that now matters. Some of the first galaxies may have been compact enough, active enough, and internally consequential enough that those old metaphors now sound gentler than the evidence warrants. The universe was young, but its local structures were already capable of urgency. Urgency without panic. That distinction matters too. This is not a story of catastrophe. It is a story of compression, of things happening close together, quickly enough that local systems begin shaping their own next phase earlier than intuition expects. A compact galaxy does not need to be apocalyptic to be astonishing. It only needs to reveal that the conditions around it supported rapid assembly and rapid consequence. That is a much stronger kind of wonder than cheap dramatic wording can provide, because it comes from the logic of the system itself. And that logic has a calm severity to it. Gravity gathers, density accelerates interaction, star formation releases energy, energy modifies fuel, the system evolves. What Webb has done is let us watch that logic at work closer to the beginning than ever before, and in doing so it has shown that some local regions of the cosmos were already passing through surprisingly advanced stages of their own development. When you really think about that, an odd tenderness enters again. Not because galaxies are fragile in any human way, but because they were transient in the physical way all active systems are. The compact, bright phase of an early galaxy may not last long, a burst ends, gas changes state, mergers transform identity, outer structure grows. What Webb catches may be a brief, intense chapter in a longer biography, and that means the observations carry a kind of accidental intimacy. We are not only seeing far away, we may be seeing moments that were never meant to endure in the form we now receive them. A narrow window in a life long gone? That is true of all astronomy to some extent, but it feels especially vivid here because compactness implies transience and pressure. A broad, quiet galaxy can seem timeless even when it is not. A dense, active one feels like a moment under strain. To observe such a galaxy near cosmic dawn is to receive a message from a system in the middle of becoming something else. Perhaps a larger descendant, perhaps a merged remnant, perhaps a faded core hidden later inside another form. The compact galaxy may not survive as itself, but the fact that it existed at all, and existed that way so early, permanently changes our understanding of what the universe could already do. This is the point where the temptation to summarize becomes very strong, and it should be resisted. The story deserves something better than summary. It deserves one more widening. Because what Webb has really done, through these strangely compact galaxies, is restore extremity to the past. Not extremity in a theatrical sense, extremity in the literal sense of conditions unlike the ones we inhabit now. A denser cosmic background, less expanded space, more immediate gravitational scaffolding in some regions, faster local inflows, more violent transitions between assembly and self-regulation. In short, a world in which matter could be forced into concentrated forms that made history run faster. We arrived late enough to inherit the quiet after effects of much of that. The sky above us is spacious because the universe expanded. Galaxies around us are often broad because they had time to grow, merge, and redistribute. Our own intuitions were shaped in the aftermath of spreading. Webb is showing us an earlier age of compression. That is why the deep past no longer feels merely earlier. It feels physically different, more crowded where it counted, more willing to push local systems into hard versions of growth. And once that is clear, the final emotional inversion begins to come into focus. For most of human history, distance has been associated with emptiness. The farther something is, the thinner it feels, the less relevant, the less textured. But these galaxies undo that instinct. They are among the farthest things we can study, and yet they are dense with implication. The great distance does not thin them out. it thickens the significance of every photon we receive from them. The farther back we look, the more we find not a simpler universe, but one whose local intensity can exceed what our late-time habits of imagination were prepared to hold. That is a difficult thing to accept all at once, which is why it arrives best as a slow realization, not a twist, a reorientation. The beginning was not empty, not even close. The beginning, in some of the places Webb can now see, was already busy enough to produce compact galaxies whose light still carries the imprint of pressure, assembly, radiation, and accelerated local time. And that realization opens the way to the ending that this subject has been quietly moving toward all along. Not an ending about data points, or even about telescopes, but about witness, about what it means that a late species in a cooling universe can look back at ancient, concentrated systems and understand, not perfectly, never perfectly, but truly, that the first darkness had already begun filling with architecture. That fact is easy to say and difficult to feel in full. We live surrounded by finished surfaces, roads already laid down, walls already standing, languages already shaped by long use. Even the natural world we inherit often comes to us in mature form, trees with rings already hidden inside them, coastlines already carved, mountains already worn by weather older than any nation. It is hard for the mind not to assume that reality becomes most meaningful only after long duration, after enough time has passed for structure to become obvious. Webb's compact galaxies disturb that habit at its root. They tell us that meaning can arrive early, that a system can become consequential long before it becomes spacious, that the first chapters of cosmic history were already capable of density, of internal differentiation, of pressure intense enough to leave marks that later ages may still carry. In that sense, these galaxies do more than revise astronomy, they revise patience. They remind us that the universe does not always unfold at the pace our metaphors prefer. Under the right conditions, matter can gather quickly, shine fiercely, and begin changing its own future almost at once. A galaxy can become crowded with consequence before the cosmos around it has aged very much at all. The old imagination wanted a slower opening because slow openings are easier to picture. They reassure us. They leave room for distance between beginning and significance. Webb has narrowed that distance, and in narrowing it, it has made the early universe feel more real. Reality becomes real to us not merely when it is large, but when it acquires friction. These compact galaxies have friction. Their light is telling us about gas forced inward, about stars forming in compressed quarters, about radiation meeting nearby fuel, about local histories becoming accelerated enough that young no longer protects us from the presence of complexity. A soft image of cosmic dawn had very little friction in it. It was easy to admire and easy to forget. A universe with compact early galaxies is harder to forget, because it behaves less like an illustration and more like an environment. An environment with costs? That part matters. We should not let the beauty of the observation make us sentimental about the process. Dense star formation is not calm abundance. It is strain as much as flourishing. It implies competition for fuel, energetic feedback, rapid change in local conditions, and perhaps the possibility that some systems push themselves into temporary quiet after intense beginnings. Compactness is not a decorative property. It is often a clue that the galaxy was living in a regime where consequences travelled quickly. A lot can happen when the room is small. That may be the deepest reason these objects feel so compelling. They make causality visible. A broad and settled galaxy can hide the violence of its own making. Time smooths things out, or at least spreads them over enough distance that our attention drifts. But a compact early system gives you a more immediate chain. Concentration leads to intensity. Intensity leads to feedback. Feedback reshapes the next round of growth. The logic is easier to feel because it is packed into a smaller frame. Even when uncertainties remain about the exact structure or future of a particular object, the basic relationship between compression and accelerated consequence becomes hard to avoid. And then something subtle happens inside the viewer. The galaxies stop being examples of astonishing space facts and start becoming evidence that the universe, from very early on, was capable of local seriousness. That word is worth using carefully. Seriousness not in a moral sense, but in the sense that conditions already mattered enough for futures to diverge. Some regions grew quickly, some systems concentrated strongly, some likely remained faint and diffuse, Some collided. Some may have obscured themselves with dust. Some perhaps burned hard enough to begin running into their own limits. Once that diversity appears, the first billion years stop looking like a single developmental stage and start looking like an uneven landscape full of branching outcomes. That is a much lonelier thought at first, and then a much more intimate one. Lonelier because it reminds us that the universe never owed us a neat staircase of simple phases. Intimate because branching outcomes are something we understand, not in scale, never in scale, but in logic. Different conditions produce different histories. Pressure concentrates change. Fast beginnings can leave long shadows. What Webb has done is uncover those familiar patterns in a realm so distant that we once expected only abstraction from it. Instead, the abstraction has thinned and structure has thickened. Structure enough to trouble our metaphors. This may be the quietest revolution hidden inside the whole subject. Not a revolution in the equations, not a collapse of the broad cosmological picture, but a revolution in wording. We can no longer casually let early stand in for simple. We can no longer let first imply barely begun. We can no longer describe the dawn of galaxies as if it were only a matter of first lights blinking on in a passive dark. The dark itself was being worked on. The galaxies themselves were already becoming internally varied. Some of them were concentrated enough to reveal that age and complexity had separated much sooner than our old language admitted. And language matters because it shapes what the mind will allow itself to see. Call a thing primitive for long enough and you stop asking what sophisticated tensions were already present inside it. Call a thing young for long enough and you stop noticing how much history can fit into youth under pressure. The compact galaxies are not a correction only to data tables. They are a correction to permission. They give us permission to imagine the early universe as physically demanding, structurally uneven, and locally accelerated without drifting into fantasy. They let us feel the burden of evidence and the burden of wonder at the same time. That combination is rare. Usually one swallows the other. Either wonder outruns discipline and becomes noise, or discipline flattens wonder until the subject no longer breathes. The best moments in astronomy happen when both survive. Webb's view of these compact galaxies is one of those moments. The measurements remain careful, the caveats remain real, the interpretations remain active and evolving. Yet the deep emotional truth has still emerged with unusual clarity. By the time the light left some of these systems, the universe had already made places where matter was living hard in very small volumes. Living hard? That is as close as language can get without pretending galaxies are people. It does not mean suffering, it means intensity. It means a lot of structural work taking place quickly. It means that a compact body of light in the early universe may represent not just the existence of stars, but a whole local history of infall, ignition, disruption, and adaptation. When we recognize that, the night sky no longer hides an empty prelude behind its stars. It hides the residue of a cosmos that got to work immediately in some of its densest corners. And the astonishing thing is that we can know that at all. We can know it imperfectly, provisionally, with revision still ahead, but truly, enough truly for the imagination to change and not change back. Enough truly that the next time someone says the early universe was simple, a part of the mind resists. Enough truly that distant galaxies measured in tiny fractions of arc-seconds can begin to feel heavier than their apparent size. Enough truly that compactness becomes not a narrow technical detail, but a keyhole through which an entire age becomes visible. We're almost at the end of the journey now, and what remains is not another escalation in information. It is the final widening of perspective that all of this has been quietly preparing. Because once you understand why these galaxies appear strangely compact, and once you understand what that compactness implies about density, speed, and early consequence, one thought rises above the rest. The universe did not wait to become interesting. It did not wait to become structured. It did not even wait very long in some places to become difficult. And the fact that we are here late enough to witness that, from within a calmer age of spread and aftermath, may be one of the strangest and gentlest privileges human knowledge has ever been given. It is a privilege because we arrived after the violence of the first compression had softened into distance, but not so late that the evidence vanished. That balance is easy to miss. If consciousness had emerged much earlier, there would have been no human-built telescope, no patient accumulation of optics and cryogenics and engineering, No long tradition of mathematics capable of translating faint light into physical history. If it had emerged much later, the universe would still be full of structure, but some of the early clues would be more difficult to reconstruct, and the direct emotional force of these first observations might be lost beneath too many later layers. We live in a narrow window where the cosmos is old enough to be read, and young enough that its earliest readable pages still shine. And some of those pages are compressed. That is what the compact galaxies finally become in the mind, not anomalies in the cheap sense, not embarrassments to be exaggerated or explained away. Pages, dense ones, pages in which the early universe wrote quickly, in a cramped hand, with little space between consequences. You look at them long enough and the old smooth version of cosmic dawn begins to feel almost sentimental. Too clean, too patient, too willing to imagine that the first chapters of galactic life must have spoken in whispers. They did not always whisper. In some regions they gathered themselves into bright, concentrated systems that could shape their own surroundings, stress their own fuel supply, and perhaps begin carrying the seeds of a later galactic history before the universe had even completed what we instinctively think of as its opening movement. That is the real weight of the observation. Not that everything happened too soon, but that some meaningful things happened sooner, faster, and in more concentrated forms than our softened intuition was built to allow. Once that settles in, the title no longer feels narrow at all. James Webb observed galaxies that appear strangely compact. At the beginning, that sounds like a shape problem. By the end, it has become a truth about time, pressure, and perception. These galaxies appear compact because some parts of the early universe were not gently sketching the future. They were already under enough pressure to produce concentrated light, rapid growth, strong feedback, structural unevenness, and in a few cases maybe even the first hints that early intensity could carry its own limits inside it. Compactness is just how that deeper reality first enters the eye. And then it enters the imagination. That may be the most lasting effect of all. Once you have really followed this story, the distant universe never quite returns to being decorative. The darkness between stars no longer feels like blank ancestral silence. It feels inhabited by prior effort, by ancient systems already solving hard physical problems in their own rough way, by matter that did not wait for familiarity before becoming organized, by local histories dense enough that their light, after crossing more than 13 billion years, can still tell us that the beginning was not smooth in the way we wanted it to be. It was active. It was crowded in places. It was already producing architecture. That word, architecture, lands differently now than it did earlier. Not architecture as polished design. Architecture as load-bearing form, a compact core, a bright clump, a dense region of stars, a merger knot, a galaxy whose visible light is telling us that structure has begun to matter. The early universe was already making load-bearing forms, already building centers, already shaping the terms on which later galaxies would grow, merge, spread, and remember. When Webb sees those forms, it is not merely finding old things, it is catching the universe in the act of becoming legible. And legibility is one of the deepest forms of awe. Not the awe of being crushed by scale, though scale is here. Not the awe of being frightened by mystery, though mystery remains. A quieter awe. The awe of realizing that reality can be remote beyond imagination and still yield enough of itself to be understood. Enough for us to say, with care and honesty, that some early galaxies were denser in light than expected, more intense than expected, perhaps more internally developed than expected, and that this matters because it reveals a young universe already capable of rapid local consequence. That is not a small sentence. It only sounds small until you live inside it for a while. Because to say that the early universe was already capable of rapid local consequence is to say that the cosmos became real in a demanding way almost immediately. Not real in the philosophical sense, real in the physical sense, capable of concentration, conflict between inflow and feedback, branching outcomes, and structural commitments that later billions of years would elaborate rather than erase. It means the first darkness was not empty waiting. It was already becoming difficult. And difficult things often become beautiful only after they are understood. That is what has happened here. The first view of compact galaxies can feel like a puzzle, a contradiction, a possible threat to older expectations. But the more carefully you stay with it, the more the difficulty transforms into beauty of a rarer kind. Not decorative beauty, explanatory beauty. The beauty of realizing that the universe was under no obligation to match our preferred emotional timetable. The beauty of finding out that young and simple separated from each other very early on. The beauty of discovering that a small, ancient source of light can carry enough structure to change how an entire era feels. And feeling matters. Knowledge that does not change feeling remains incomplete. By now the feeling should be different. The sky overhead should seem calmer, but not simpler. More peaceful, perhaps, but only because we understand a little better what preceded that peace. Galaxies around us should feel more layered, more like settled outcomes than default forms. The phrase cosmic dawn should feel less like a watercolour and more like a compressed age of intense local beginnings. And those strangely compact galaxies, so small on the detector, should feel larger than ever in implication, small in extent, vast in what they reveal. Perhaps that is the final image to leave in the mind. Not a gigantic thing, but a concentrated one. A tiny patch of ancient light on a sensor, so faint that only one of the most sophisticated instruments our species has ever built can register it properly. And yet inside that tiny patch is a report from a time when the universe was still near its beginning and already busy enough, in some places, to build dense islands of consequence, already busy enough to create galaxies that were not just there, but already becoming themselves under pressure. We are very late witnesses to that. Late enough to inherit the cooled, widened aftermath. Late enough to mistake calm for origin. Late enough to need a telescope to undo that mistake. And fortunate enough to have built one. So the next time the night looks quiet, it may still look quiet, but perhaps not innocent. Somewhere in the depth behind that calm is the memory of an age when some of the first galaxies were compact enough to reveal the harder truth. The universe did not begin as a simple draft of itself. In places, it began crowded with intention, compressed with energy, already writing long futures into very small spaces. And the astonishing part is that, all this time later, we can still see those first tight knots of light and understand that the darkness was already full of structure long before it ever felt like home.